part 7. This problem's crazy, so let's get into it. So Leaning Tower of Pisa. If you don't know what Leaning Tower of Pisa is, I'm sure you've seen like a meme somewhere on the internet where like people are like trying to like push the building over. It's a fairly famous building in Italy that was built on a really terrible foundation in a really terrible area. So over time, the building is literally falling down. But it's such a work of art, they keep it kind of restored to its natural state. So they're never actually going to try to fix this thing, right? Which creates some really interesting opportunities for like a problem. Now there is an observation deck. You can kind of see it right here. Okay. Oh, so like this. See the railing here. You can actually stand there. You can go to the top of the tower and actually stand on the observation deck. It's not free, but you can stand there. Although the part about the wishing well is a bit dubious, all right? But we can still solve the problem. Now the key to this problem is really visualizing what's going on. So I'm going to try my best to kind of diagram it. Right, so again, you have to kind of think about good diagramming like theory. Every line has to represent something, all right? So here's what is going on. All right, so you have this tower, all right? And the natural position of the tower should be at a 90-degree angle. That's like where it should be. Now that's not where it is. So over time, this tower has started to lean. And as in the first part of the problem, we're examining a tilt of 5 degrees. So I'm going to exaggerate it, but let's say the tower is there, and the tilt is 5 degrees. Okay. Now at the top here, a torus can stand, and so if you go 150 feet up the wall, like up the actual tower, there's an observation deck at the very top, and then you can actually stand here and you can drop pennies into a well. Okay, now this well is movable, it's for the tourists, but the well is right here, okay? And the well is a certain distance over from the base of the tower. Now you can kind of see it set up here, you are looking at a right triangle. Now, something happens over time, this thing continues to lean. Wow, what just happened there? Okay, so this thing continues to lean. So it was at a 5-degree tilt, and I know it's written kind of messy, but that is 5 degrees. Okay, the tower keeps tilting, say about right there, and this is now a 9-degree tilt. Right. Now the well is obviously they want tourists to keep like throwing money into the well because that's a revenue source. So they're going to have to move the well farther over. Okay. Let's do some different color blue. Okay. And again, since we're dropping it straight in, that should be a 90. So now the question is, of course, how far do we have to move it? And so the big question here is, what is this distance, which I'm going to call x. So if you watch the other parts of the video, if you tried the other problems, you know this is a it's a very complicated problem, but it's not a tough one. What you're really looking for here is just like a final kind of solution strategy. Like, what do we have to work with? Now, one thing to note is the tower didn't get any bigger, and so the distance here is still 150 feet. To solve this, what we're going to have to examine is really the bottom. If I want to find x, I'm really going to have to find two distances. I'm going to have to find this whole distance, which I'm going to call, I don't know, distance r. And then I'm going to have to find this distance, which I'm going to call s. And then using those in subtraction, I should be able to find x. Like if I have the whole distance r and I take away s, it should leave me this little section here, which I'm referring to as x, all right? So let's look at the bigger picture. I do have two triangles here. The angles are not given to me directly, but if I'm clever, I can figure them out. The tilt off the center is 5 degrees for the first one. That would leave this angle to be 85 degrees. In the same sense that if I'm 9 degrees tilted from the center on the second case, it would leave this one to be 81 degrees. And those are the last pieces I need to actually solve this, because I know the tower stays 150 degrees. I'm 150 feet, and so like the tilt off the center should give me the degree of my triangle. Now again, the degrees in our triangle are not 5 and 9. they're 85 and 81 because it's a tilt off center and the rest are going to form my triangle. All right, so let's do it. Let's find, I don't know, let's find R first. So we're going to find the whole distance, which means we're going to find like this greenish triangle, the one that's kind of in the green line. I'm going to need a reference angle. So I'm probably going to pick 81 because that's the one I actually have to use. So if it tilted 9 degrees, it should leave 81 degrees left. That's how I'm getting 81. I have 150, which is my hypotenuse. I'm trying to find my adjacent, which in this case is R. So let's set it up, reference triangle, actual triangle. I need adjacent over hypotenuse, in this case for 81 degrees. Then adjacent over hypotenuse for 81 degrees. And those should be the same, of course. In my actual triangle, my adjacent is my R, the big distance. My hypotenuse is 150. Let's go here. Now, certainly 81 should be right from the top, but I'm sorry, from the bottom. I need A over H, which is the very first column. So 81 degrees for A over H, 0.1564. Okay, so again, I'm just going to go to algebra here. Let's multiply both sides by 150. That should do a nice job canceling that out. So it actually should give me a nice R value here. So R is equal to 0.1564 times 150. All right, so R in this case is equal to 23.46. Okay, so if you think about the context of the problem, 23.46 is R, okay, which means it's the entire distance. So like at a 9-degree tilt, this well should be 23.46 from the inward base of the tower. Now, of course, we have to find the other one as well. So let's find S. You're going to see a very similar setup. So reference triangle equals actual triangle. I'm also going to need the same two pieces because S, if you're looking at S here, so S is going to be the small base for the 85-degree triangle. So I'm again use adjacent over hypotenuse, but this time for an 85. And for my actual triangle, again, adjacent over hypotenuse for an 85. In my actual triangle, my adjacent is going to be my S. Hypotenuse is still 150 because of building and shrinking. Let's go to our trig sheet. Adjacent over hypotenuse. Once again, let's double check. Yeah, it's going to be in our first column, 85 degrees. So it's going to be 0.0872. Okay. And so now we are solving. So again, I'm going to pull the same similar trick. I'm going to multiply both sides by 150. That'll kill the left times 150 here. So 150, 150 times 0.0872. So I'll give, so like the 5-degree tilt, this basket is, where is it, 13.08 feet from the base of tower. So that's actually going to be that one, okay? So now if I want to find x, I'm going to have to subtract the 2. So I'll take the 23.46, subtract off the 13.08, which inexplicably has changed to green. So x in this case should be about 10 feet, so 10.38 feet. So that's how much farther you have to move the basket to put it in position. So it was here, you have to move it 10.38 feet to get it where it needs to land for the tourist. Pretty neat, huh? Okay. So I think that's part 7. I'll see you guys in part 8, which should be the last part. Yay.